As we have been getting to observe in the rest of the units, one of the objectives of the LIFE-myBUILDINGisGREEN project is to raise awareness of how school buildings and centres can be adapted to climate change using nature-based solutions. The Provincial Council of Bad Hof, through the Rural Development and Sustainability Area, and as part of the project's actions, after a selection process, chose the Gabriela Mistral School in Solana de los Barros as a pilot building in which the provincial institution has implemented prototypes and solutions to adapt to the consequences of climate change, and more specifically, those derived from heat waves that affect the most vulnerable users of buildings. We see how every day news items appear in which rising temperatures are the protagonists, and how maximum temperature records are continually being broken in the province of Bad Hof. This causes the now commonplace heat waves, which means that as a preventive measure and as the only solution, many schools have to reduce their timetables to combat the problem. They also cause other extreme consequences, such as floods in rainy periods or droughts in summer periods. These problems are not local to our geographical area, but are a real climate problem that affects the whole of Europe. What can we do about climate change? On the one hand, we must offset its effects, and on the other hand, we must adapt to the real change that already exists. How can we mitigate its effects? By reducing greenhouse gas emissions, by reducing energy consumption. Building in the Northern Hemisphere is one of the areas where we can achieve the most with the least investment. Although we continue to work on mitigation, we must adapt to the reality of climate change, and we cannot do this by installing artificial cooling that increases greenhouse gas emissions, but through passive measures such as shading or ventilation, traditional measures of bioclimatic architecture, and in this case, through the use of nature-based solutions with the presence of biodiversity. In the case of the consequences of flooding, it is advisable to use sustainable drainage systems, reforestation, and the creation of protective infrastructures. In the specific case of the Gabriela Mistral School in Solana de los Barros, we have a building chosen for its ideal architectural configuration, ideal for testing and trying out the implementation of nature-based solutions. We have a central building, the oldest of the existing ones, with a hipped roof and a new annex module built in 2006, with flat roofs at different levels, ideal for the incorporation of NBS, nature-based solutions. The facade we see has an east-southeastern aspect so that it receives a lot of sunshine throughout the school day. Here we see how the two buildings are interconnected. A glazed corridor without any kind of solar protection, which the school has dubbed the Corridor of Hell, due to the high temperatures reached inside because of the greenhouse effect. For all these reasons, the building could be fitted with various passive measures. With the help of the Cartier Foundation and the Eduardo Torroja Institute of Construction Sciences, a sunlight analysis of the school was carried out, and depending on its orientation and volumetry, it was possible to study how to incorporate these shading elements as an effective main measure to reduce the high temperatures. Based on the initial idea of the LIFE project, the following prototypes were designed in the annex building based on traditional passive measures that incorporated innovative solutions, acting on the envelope and on the exterior spaces. The inclusion of vegetal roof covers of various types, like extensions with improved substrates, or on trays designed to generate cold frames. Shading of facades pointing to the east, southeast using natural solutions, using the prototype called FAVE, vegetal facade. Outside use of shades by means of vegetal pergolas, PEVE prototype, and the creation of vegetal drainage soils, so that rainwater flows, so as to make the rainwater flows avoid flowing into the municipal stormwater systems, but rather to filter into the ground. This is about the SUVE prototype. The aesthetic result of the various implementations could be very attractive by modifying the appearance of the facade. The building also has the oddity that the roofs can be visited by children, so they can be used as an educational resource to show different options based on nature as solutions to climate change. The Fachada vegetal prototype is designed as a substructure, backed by the facade that serves as a support for the planting of deciduous plant species, allowing sunlight in winter and generating shade in summer. The FAVE system on the date of the work carried out cost approximately €190 per square metre, including the structure, pots, plant species and a proportion of the irrigation system. Conceived as a modular, demountable system with the possibility of being replicated in other buildings, small-scale prototypes were made before the work was carried out to study the ease of assembly and disassembly. A three-dimensional structure of bars of standardized sizes with bolted joints was conceived, facilitating manufacture and use in different buildings. The deciduous plant species chosen for the facades were the Tricuspidata and Quinquefolia varieties of virgin vines. In the case of roofs, the project established different typologies to be tested on the different roofs of the building. Extensive roofs, using recycled aggregates as part of the substrate, or rock wool, were combined with roofs resolved with elevated trays to generate cold roofs. The necessary maintenance paths were also provided. The average cost of the green roof prototypes was approximately €164 per square metre on site, including the proportional part of the common irrigation installation provided for all prototypes. The renovation consisted of removing the entire package of the existing inverted roof, gravel, geotextile sheet, thermal insulation and the last geotextile separation sheet, and covering the waterproofing. Although the condition of the waterproofing was correct, due to the time that had elapsed since its installation, it was recommended that it be removed and a new waterproofing system be installed. Thus, a new facility began with the installation of a new synthetic PVC sheet, which is always preferable to asphalt sheets, as the latter contain components of organic origin to which plant species are attracted. Perhaps the most important aspect of the green roof construction solution is the incorporation of a drainage sheet compared to the traditional inverted roof, as well as the provision of anti-root and separating sheets. The drainage sheet must be a specific product for these solutions, with sufficient drainage capacity to guarantee the functioning of the roofs. The substrate should be at least 10 to 12 centimeters thick, so that the plant species can have a certain depth for the roots. This new load can be compensated for by removing the protective layer of gravel that has been removed, although each case will require the relevant load study. If the structure is prepared, greater thicknesses can be used, which would allow other species to grow. In this image taken during the construction work, the different profiles used to delimit the different types of roofs and traffic transit areas can be seen. It is also important to respect a safety distance from the planting areas to the edges and special points, drains, etc. The supports of the FAVE system, when they are on roofs, are placed on the separating sheets above the waterproofing. All the prototypes on roofs, facades and outdoor pergolas require a drip irrigation system designed in accordance with the planned distribution of plants. The irrigation system is a fundamental element in the whole set of solutions based on nature, especially in the climate in which we find ourselves. Although plants with low water demand have been sought in order to guarantee the growth of the species, especially in the early years, an adequate water supply is required that does not depend exclusively on rainfall. The system is programmable and allows the incorporation of fertilizer to facilitate plant growth. The installation has a system for collecting and storing rainwater and excess irrigation water for reuse. Shaded areas can be installed in the outdoor areas using the same deciduous plant species. The cost of these systems is around €93 per square metre. As a prototype of the draining soil, there were areas of continuous paving with porous concrete and areas with paving made of filtering paving stones. In both cases, rainwater is filtered into the ground, where a ditch and a filtering well were installed. All of this avoids the discharge of rainwater into the sewage system, avoiding its unnecessary treatment and the corresponding energy consumption. The approximate cost of the systems per square metre is around €30. A prototype of a vertical garden was installed inside the building, which seeks to cool the environment thanks to the evapotranspiration of the plants. These installations also absorb CO2 from the environment and are a great visual attraction. The presence of nature as wall cladding inside buildings is recognized as having positive psychological benefits for the occupants. Once the installations were completed and through a participatory process that sought to define other solutions to combat climate change, the educational community decided to gamble on for more shaded areas. A pergola was built with natural wood slats of copper-treated pine superimposed on a metal structure. In the first year of monitoring the building, we observed a decrease in temperatures inside the areas of interaction of between 8 and 11% compared to the original temperatures. The thermographic images show, for example, the temperature differences between conventional roofs with a pea gravel finish, where temperatures reach up to 48 degrees Celsius, and the laid green roofs, where surface temperatures drop down to 29 degrees Celsius. With the investments made, it only remains to analyse to what extent these solutions are more or less suitable for adapting buildings to climate change, compared to other measures such as the installation of artificial cooling features, also taking into account the psychological and educational benefits of the nature-based solutions used.
Nuestro centro ha estado muy concienciado con el cambio climático, pero a raíz de la implantación de My Building is Green, dicho proyecto forma parte dentro de nuestra programación general anual. Nunca pensamos que plantar miles de parras fuera la solución para mitigar las altas temperaturas que se alcanzan en nuestro centro.
In collaboration with the LIFE program of the European Union.